Now you are given this question to prove that 1 minus tan square x divided by 1 plus tan square x will give you what? Cos 2x. Now, how are you going to solve this? So pay attention. I'll be using a systematic method to solve this, recalling all the trig identities that will help us to simplify this question. So recall that sine x all over cos x is equals to what? Tan x from basic trigonometry. Therefore, sine square x all over cos square x is equals to what? Tan square x. So what does it mean? It means that we can use this fraction and substitute for tan square x back in the question. So we have 1 minus tan square x, and I can write it as what? Sine square x all over cos square x. Now divide, I can separate it so that it gives more clarity. 1 plus sine square x all over cos square x. Now what do? Let's simplify the fractions. Now the LCM of this is what? Cos square x, because your 1 is something as what? 1 over 1. Your 1 is also a fraction. So now cos square x divided by 1 is cos square x times 1. You have what? Cos square x minus cos square x divided by cos square x is 1 times sine square x. You have sine square x. Now divided by the LCM also is cos square x. Now cos square x divided by 1 is cos square x times 1 cos square x plus cos square x divided by cos square x is 1 times sine square x, sine square x. So what do we do next? You have what? Cos square x minus sine square x all over cos x. Now you can change this to times. When you change this to multiplication, what happens? You what? Invert the fraction. It becomes what? Cos square x all over cos square x plus sine square x. So what do you have? Cos square x and cos square x can cancel out. So we are left with this expression. But these are also simplified with identities. Recall that what? Cos square x plus sine square x is equals to 1. So this expression here is 1. So what do you have? You have cos square x minus sine square x all over 1. But we are asked to prove that this expression is equals to cos 2x. So now how do we simplify this to cos 2x? Now, if you recall from your compound angles, we have what? Cos 2x is equals to what? Cos square x minus sine square x, which is equals to what? 2 cos square x minus 1, which is equals to what? 1 minus 2 sine square x. So it is very important that you recall these trig identities. Now, among these three, which one suits this? Cos square x minus sine square x is cos 2x, right? Is equivalent to this. So we're going to use this to substitute for this back in the equation. So now we have proven that this expression is equals to what? Cos square x minus sine square x gives you what? Cos 2x. That's how you prove this identity.